This says we're going to graph each quadratic function, name the vertex, axis of symmetry, the maximum or minimum value in the domain and the range of each function. And I'm looking at number 1 and hoping you can tell me, is that vertex form or is that going to be standard form? Vertex form. So y equals 8 times the quantity x minus h squared plus k. So vertex form ought to be able to give us the vertex like pretty quickly, right? Why it says 2, 3, is he right? Yeah, because it's always the opposite of what we see here. And if we know that, isn't it really easy to get the axis of symmetry if you know where the vertex is? It's 2, but we need an equation. X equals 2. There it is. So we know where the new vertex is going to be. We know where the axis of symmetry is going to be. The rest of this, it would be really helpful if we had it graphed first. So we graph it. We go back to the shape. The shape is y equals ax squared. Now, does this have a new a value? A different a value than we've had before? It's a 1, isn't it? So really, we could just make a quick little table for like 0, 1, 2, and 3. And we could square those, and that will give us the basic shape graph that we need. And that's going to be 0, 1, 4, and 9. And like I said, you know, when we did this, it came back really easy to you because you've done it forever in exponential. But we've got 0, 0, 1, 1, 2, 4, 3, 9. And I realized that's only half a parameter. So then I have to think, how do I get the other half once my eraser finally works? Do what? Reflect it over. Yeah, that's exactly what we do. So basically, you count on the other side of the y-axis. This was 1 away, so this is 1 away. This was 2 away, that's 2 away. That was 3 away, that's 3 away. That's not our final product, so we want to make sure this is dashed or dotted. Like so. Because we said the vertex is not 0, 0. We gave it a new vertex. So how are we going to move that one to get it to its new spot? Where do we go? 2 to the right, 3 up, because we need that new vertex at 2, 3. So we're going to take 0, 0 and just count and go 2 to the right and 1, 2, 3 up. From 1, 1, we're going to go 2 to the right and 1, 2, 3 up. And from 2, 4, 1, 2 to the right, 1, 2, 3 up. And yeah, even though it's probably going to be a little bit off of my graph, I'm going to take that 3, 9 and also try to go 2 to the right and 1, 2, 3 up. But again, that's only half a parabola. So we need to draw in that new axis of symmetry, which was at x equals 2. That way, we can just reflect it over again, like Wyatt was talking about earlier. Reflect it over. So we're going 1 over this way, 2 over this way, and 3 over this way. And there's our final graph, all beautiful. So you don't have to use extra colors for this. What you can do is the dashed and the solid, but it sure does help to see where that new line of symmetry is, that new axis of symmetry at x equals 2. So, yeah. And what some people do is they go, well, this will be like my new 0, 0. So I'll just go over 1 and up 1, over 2 and up 4, over 3 and up 9. Yeah, and use it that way. The difference comes when there's not a 1 in front of the x squared. Then things get a little bit different and we have to go the color. But with 1x squared, it would be the same. All right, so does this one have an x or a min? It has a min. It's got a bottom number right here. Well, what is that? Our vertex, isn't it? Isn't that what we said it was a 2, 3? So that's our minimum. 2, 3, right there. Yeah, because we can put anything in here for x and we can do the math. That's going to be all real numbers. But we are not using all the y's with that little graph. We are not. So how do we describe which y's we are using? Y is greater than or equal to 3. Good. 3 and above. I mean, that's what we said about our vertex. It was 2, 3. And the 3 is the one that tells us up and down. So there it is. Alrighty. Ooh, 2 does not look the same as this one. So is 2 in vertex form? No. This is standard form, and that's y equals ax squared plus bx plus c. There it is. All right, so what do we need to do? Well, we need to come up with a way to find the vertex. You remember the formula to find the vertex? Negative b over 2a. And sometimes it's helpful to stop and say, okay, here's what I know. A is -2, b is -12, and c is 11. So you've got it all written down. So we need negative b over 2a. Did not start to look like a -2. So what will we get for the export? 12 over -4, which would be -3. So far for our vertex, we know it's -3 something. How do we find the something? Yeah, plug it back in. So let's see what we get. With a -3 in here, it'll be -2 times, well, -3 squared, but that's 9. So I need some space. -18 minus 12 times -3 would actually make that plus 36, and then plus 11. -18 plus 36 is 18. 18 plus 11, 29. So that means I'm not going to be able to go by ones on my y-axis, or I'm not going to fit this graph on. I know I have 10 little slots, so I probably better go by 3s, because 3 times 10 would give me the 30. So I'm going to put a little 3 right there to show people, hey, my y's are going to have to go by 3, not my x's. My x's are, -3 is a small number, so it's not anything to worry about. But the y's, we've got a big one. So what's the axis of symmetry? X equals -3. Let's see. Now we better get a graph so we can figure out whether or not this has a max or a min. Our vertex is at -329, so 1, 2, 3, and then I went by 3s, so almost to the top. That's where my 30 would be right at the top. That's not 4. I'm going to need at least one set of good points for this. Now, this is the one thing that standard form did nicely. What do we get for a nice point? Anybody remember how we get kind of a 3D point in standard form? 0C. Always a nice point on this graph. What was our C value? What do we have for C? 11. So 0, 11, 3, 6, 9, and not quite 12. Well, again, you could say, well, that's only half of it. Well, let's put our axis of symmetry on there. And then we can do some reflecting. This is 3 units away from the axis of symmetry, so let's go 3 units away on the other side. And boy, if that's homework, I'm making my parabola. But this is supposed to be a practice test, so I probably want at least one other set of nice number stuff. What would you put in? What would be another one that maybe would show us the spread a little bit better? Can't finish it until we have another point. What do you want to put in for x? Well, 1 is good. Yeah, 1, 2, something over here to help us have some aim. 1 would be good. So we'd have -2 times 1 squared. Well, is 1. So negative 2. 12 times 1 is 12. Minus 12 plus 11. Negative 2 minus 12 is negative 14. Exactly. Well, that's a pretty good spread now. And we can use symmetry to go equal but opposite on the other side. 1, 2, 3, 4. Apparently I'm not allowed to erase. So does this one have a max or a min? This one has a max. It has the highest point. What can we use for x's? Are there any x's we can't put into this? So what do we put? Guess I got a column. Kyle, what do we put for the domain? Yeah, our real numbers. Maybe you're not shy, maybe you're just all doing it, right? Because I see everybody's heads down and they're right there. So then we need the range, which is a little tougher. I mean, you have to think about how we got the numbers that we have there. So, Cade, what would you put for the range for this one? Exactly. Yeah, this was our highest point up there at 29. So there it is. Y is less than or equal to 29. So, something like that's going to work out. You know, we just spent a pretty good chunk of time doing these two graphs. I want you to 43210 me on if that's the first part of this test. How's it going to go? Pretty good numbers. I think some of you are underestimating yourselves. Those of you that have twos, because when we did this in class and you guys did the homework, your homework was really great. So I think with a little bit of review over 2 days, and if you do the homework, I think you're going to be set. So 1 vertex form and 1 standard form. And then this one says, don't graph it. Well, we shouldn't have to. We didn't have to do a whole lot of graphing to get important stuff from the last one. Without graphing, name the vertex, axis of symmetry, the maximum or minimum value, and the domain and range, and the transformation of the function when compared to the parent function, f of x equals x squared. I'm really glad there's blanks here for all of that, because it's like a part A, B, C, D, E, F, for goodness sake. There's all kinds of stuff going on there. So, is that vertex form or is that standard form? Okay, let's put that up there then. Its name came from the fact that it's supposed to be really easy to find the vertex. So the first thing I'm going to want to know is, where is the vertex? Where's our vertex on this one? 3, 2. That's right, because we've got this negative and we have to think opposites of what's in the parentheses. And every time we've done this, we've been able to do the axis of symmetry really fast once we had that. What? What about 3? Good. So it has to be the equation for a line. So x equals 3. Question mark. You want to do the next ones? Hang on. Oh, it's got this graphing inside and out. Alrighty, so I want you to think about what this looks like. Draw in the air for me, right in front of you, what this parabola is going to look like. So good, everybody's giving me an upside down parabola. And we kind of do that sketch in our head. I know it's said without graphing, but you could write it down. I don't care, it's a sketch, it's not really a graph. So the next question is, does it have a max or does it have a min? Jason, what does it have? It has a max. And where is that max? Yeah, max of 2. Right there. So our max is at 3, 2. The highest point is a 2. So now we need to talk domain and range. And domain is going to be about the x's. Blake, what do we know about the x's for these domains? Yeah, that's kind of the gimme, right? because whenever we're dealing with quadratics, we can use whatever numbers we want. But the range, yeah, you have to think about that for a second, about what that top y value is. Riley, what should we put down there for range? Great. That's our highest point up here. Like I said, even just this little sketch right there. That's all we need. Now, they're saying, okay, let's talk about transformations. If we start with this, the parent function, what is each number telling us that we are supposed to do with this graph? Oops, question here. Because this front number has a negative in front of it. That always tells us it's reflected over the x-axis. So that's where that was coming from. Alrighty, so the first thing we're going to deal with is this negative 4. It tells us two things. I'm going to call on somebody to give me one of the two things that it's telling us. Carson, what's one of the two things that negative 4 says? One noun, and that's a reflection. Reflect over the x-axis. So we've got the negative taken here. We need to know what the 4 is doing. So, Ryan, what's the 4 telling us? Good. Vertical stretch. Factor of 4. All right, now we keep going left to right. Next number we come across is that 3. So, Ben, what's the 3 doing? Well, you can use the right hand to work with 3. Translate 3 units to the right. Translate 3 units to the right. I'm just going to put and then pick somebody to tell me what's going on with the plus 2. Anna, what's going on with the plus 2 in the back? I'm just going to put and up 2. Not at all. Now, if on the test this were negative 1/2 instead of 4, what would be the big difference between those two graphs? And this is a volunteer one because it's a little harder. So if this said y equals negative 1/2 x minus 3 squared plus 2, what difference does that number make? Yeah, it's a vertical compression instead. Remember, if numbers bigger than 1, stretch it out like it's made of rubber bands. But when we have a fraction between 0 and 1, we're squishing it down, and the fancy word for that is compression. Wow, that's great for everybody. I really like that Ben was even using the word translate. Sometimes I'll ask that, and people will just say, right 3, up 2. Using that language is really good. Good job. So, 4, 3, 2, 1, 0 me. That's on the test. How are you going to do? Where's your confidence at? Good. Okay. Because we got to do the word problems next. All right. The students in Mr. Wilson's physics class are throwing golf balls. Keeping track of stuff. Throwing those golf balls in there. The flight of Group A's ball is modeled by this equation. Well, that's not a very friendly equation right there. There it is, decimals and all. Where the height y in feet can be written as a function of x, time, in seconds. Does this parabola open up or down? Which makes perfect sense. They're throwing the golf ball up and then it's coming back down. So I want to think about a sketch. It's not a graph. It's just a sketch where I think, okay, so what are they doing? They're throwing the golf balls like so. That's what they're doing. So I do want to label which one's supposed to be x and which one's supposed to be y here. And it says x is time in seconds. And then y is, of course, height in feet. Right there. And the picture makes sense with what we know. So the question for A is, when did the golf ball reach its maximum height? So now, here's where we find out we have choices. If we don't want to use the graphing calculator because yesterday you were trying to do left, right, right, and left, and it didn't work, you wouldn't have to. We have a formula to find the vertex of this that we can use. What's that formula? Yeah, and what is that little formula? Negative b over 2a. So you would not have to use the graphing calculator for this problem. All you would do is negative b over 2a, so negative 0.68 over 2 times negative 0.14. That would give you your x-coordinate. Plug it back in and get the y, and you can answer these questions. But I would at least want to check. I don't know about you, but I would at least want to check. So let's get this into the graphing calculator and see what we have. So you've got two choices. You can show the work and you can do the algebra for it, or you can grab your graphing calculator and let the calculator find the numbers for you. So into y equals we go, and we need negative 0.14 x squared. Make sure you use the negative and not the subtraction. It'll yell at you in a minute if you do that. Plus 0.68 x plus 6. So negative 0.14 x squared plus 0.68 x plus 6. Well, negative 10 to 10 probably isn't going to do this. So let's go to the window. How long do you suppose the golf ball will stay in the air if you go? Just kind of think about it and kind of count to yourself. How many seconds do you suppose that will? It does. So somebody stronger might be able to have it in there a little bit longer than you would. So what should you maybe try? 10 seconds? Okay, somebody pretty strong maybe can do 0 to 10 seconds here. Oh, well, I already have that on there from the other problem. Then the other part's a little bit harder, and that's because we're talking about how far somebody could throw it. And again, that's going to be different depending on who the person is. I guess I'll try 25 feet. If it's not enough, we'll see. You know, let's just see. Because it could be in a problem that you get on the test, you're kind of unsure about those and you're going through this process. And you realize, well, there it is. I mean, that's really what I need to see. I don't like that there's all kinds of white space up here. So what was that about? 1, 2, 3, 4, 5, 6. So 6, 7, and 8 maybe is the height of this. So if I go back to my window, I can actually change my y's so they're not quite as high as they were. And it might give me a little bit better look at the parabola. So let's try maybe 10. Don't get me wrong, Blinky would do the math. On that window we just saw, Blinky will do the math. But I just wanted to see it a little bit nicer as a parabola to do that. Now, do you remember where we can find that maximum height? Second, trace. Second button, trace. Which one of those do you suppose we use to find that top height? And all we have to do is get Blinky on the left side of the hill and press enter, and then on the right side and press enter. But you have to make sure Blinky's actually going down, because it's going to yell at you and tell you that you didn't see a sign change if Blinky's not going down on one side. So, take a little bit here since my key doesn't work when I hold it down. Well, it's still not working today. And you can see when you get to the top how there's a pixel there where Blinky starts to drop down. And that's as far as you need to go. You could actually go a little farther. Something not happening. Oh, you don't need to change that. That has to do with if you're graphing inequalities, what you want the shading to look like. And since we're not doing any shading, we don't care. So we'll just change. No, it's okay. Alrighty. So, Blinky asked me if that's on the left side of the hill, and I press enter. And then I've got to move Blinky to the right side of the hill. Boy, I wish that feature worked. And again, I have to wait for Blinky to start coming down. And then anywhere over there, hit enter, and enter your guess. We don't want to take a guess, we're using Blinky. So Blinky says, there's your vertex up there at about 2.4, 6.8. And now we're going to use that to answer the questions they have for us. Because right here, we know this is 2.4 and 6.8. So, when did the golf ball reach its maximum height? Got to be one of these two. Which one of those is a when? 2.4? How do we know? X is time in seconds. That's a when. That is 2.4 seconds. What's the maximum height? Yeah, that's our height right here. The Y value is height in feet. And then it says, Bobby throws the golf ball to Connor. He makes a spectacular catch of the ball 6 feet above the ground. How long was the ball in the air? So that means this is a 6. And what we could do, if we wanted to do this by hand, is we could subtract 6 from both sides, and this would be factorable. We could factor an X out and we could get the answer. So we wouldn't have to use the graphing calculator. But I'm going to show you a new feature, because you could get a 0 over here, plug it in your calculator and find the zeros. But there's a nice, easy way to do this if you know what height you want it at. So I go back to my graphing calculator, and I'm not going to change that equation at all. But what I want to know is, when is it 6? So I just make y sub 2 6. And I want to see, when does this hit my graph at 6? So I hit graph. And it's right there. And I'm pretty sure we have used this before to find an intersection. And that's what we need, is we just need to find the intersection. So do you remember where that is on the calculator? Yep, second trace again. Number 5. And then basically just hit enter 3 times, because Blinky knows, hey, those are the ones we're talking about. So 4.9 seconds later, because this is when the ball was thrown, this is when he made that spectacular catch. And that was about 4.9 seconds later. Now, as I said, you would not have to do any of this on the graphing calculator if you didn't want to. You could take this equation, write this down as A, B, and C, do negative B over 2A, get a number, plug it back in, get the Y value, and for this one you could put the 6 up here, subtract 6 from both sides, and factor it, and you'll be able to find the answers. So if you're worried, hey, this graphing calculator stuff isn't coming to me yet, it's okay. You can do it by hand. You don't have to use the graphing calculator for this. Alrighty, let's do the other wordy problem. To make an enclosure for, that's right, chickens. To make an enclosure for chickens, a rectangular area will be fenced. There is 120 feet of fencing material. Well, that's perimeter. A says, what quadratic function represents the area of the rectangular enclosure? What? All they gave us was one number. 120 for all of it. Okay, well, I'm going to start here. I don't know what that is, but I know that's the same something, because that's how rectangles work. Whatever you get for one side, you have to get for the other. Gosh, so I got to figure out something to put in for the other two sides. Because we have to find. And how do you find area? Oh, we can't use two variables, otherwise we'll need two equations. But that's a good way of thinking about it, Abby. We want just one equation out of this. You meant y, the variable y. All right, so here's what I know. If I add all of this up, it's supposed to equal 120, right? So let's see here. I don't know what these are, but I know that x plus x is 2x. So I can subtract what I already have over there. But don't these two have to be exactly the same thing? So wouldn't I have to split the remainder into two? So if we have the 120, that's a good place to start. And then we say we've got x's in these two slots, so we'd have to subtract 2x to see what's left. But now there's two sides that have to be exactly the same thing. And I'm not going to leave this. What would this simplify to? 60 minus x. Now we're on our way, because now we'll be able to just have one equation with one missing variable, which, by the way, hinges on the fact that we know how to find area of a rectangle. How do you find area of a rectangle? Yeah, length times width, base times height, however you learned it. X times 60 minus x. We can do that now. We know how to distribute. 60x minus x squared, and I would probably reverse it so that I could see, oh, yep, this is a down opening parabola. That's what I have here. And then it says, what dimensions will maximize the area of the enclosure? Okay, well, we could put it in the graphing calculator and we could find the max again. Or we could do this one by hand and say, that's factorable. In fact, we just saw it factored up above there. Let's see, which one do we probably need more practice with? You probably need more practice with the calculator, right? Okay, so let's go to the calculator. Negative x squared plus 60x. There you go, on your machine. Okay, so with this one, we're talking about area. And that's probably going to change my window a little bit. So let's see, the perimeter was 120. If everything was divided equally, there's 4 sides, so that would make each side 30. So let me just try 0 to 40 and see if we get a good look at a parabola with that. And let's see, if it were 40 by 40, that would give it an area of 160, so I need this number to be a little higher. Again, if you don't know what to put in any of these, hit zoom 0. I hope that the calculator will fit it in for you the way it's supposed to. But I would just play around with the numbers a little bit. See that? Well, I'm not seeing the top of that thing yet. So it looks like I don't need as many x's as I have in my window. I need my y's to be higher. Negative x squared plus 60x. I'll try 240 this time. Still not seeing the very top of this thing. What are you trying? What's your biggest number so far anybody's tried in the line? Now we're getting close to being able to see it. It looks like it's going to be at the top of that. So now if we increase our x's, maybe 50, since it looked like it needed to be about twice as big. And this is just the process you go through. If you don't know what the answer is, you just keep messing with the window. So now if we can see the top of that, Blinky can see the top of it? Okay, so we'll let Blinky find it. How do we get it again? Second trace. Which one? Nope. 4, max. Ooh, Blinky's right in position this time. That's nice. Get Blinky over to the right side. Press the right bound. Come on, Blinkster. Make it happen. There we go. And enter your guess. Well, what do you suppose will round 29.99999952? Yeah, 30. So what dimensions will maximize the area? 30 by something, so 30 feet by, well, what happens if we put 30 in here to get the other side? What's 60 minus 30? 30. All that work to find out it's a square. That maximizes the area. Believe it or not, that shows up on the MCAs and the ACTs all the time, and it's always a square. If you want to maximize the volume or maximize the area of any rectangular area, a square does it. That's when you get it maximized. Again, you wouldn't have had to use the graphing calculator. You could have factored this and used that information to get it, or better yet, you could go ahead and, if you factor it, you're finding the zeros and the vertex will be halfway in between. But if you just want to go after the vertex, you could do the negative b over 2a and get it that way too. So you would not have to use a calculator for any of this if you don't feel comfortable with that. All right, our two little wordy problems. 43210 meet on the two little wordy problems that we have here. Yeah, they're a little tough. Yeah, just the fact that there's words scares us a little bit. All right, so that's as far as we're going to go today. Make sure your name's on those and pass them up.